This is AQA question 2 on page 189. It's a lovely little question. It says, the sketch shows the graph of y equals, let me write it for you, this is the equation, y equals x cubed minus 3x minus 8. And the graph looks like this. So I've been given a pair of axes like that. There it goes, like that, something like that. And they've called this the point A. They've called this the point 2 minus 6. They've called this the point 3, 10. And here we go, y-axis, x-axis. Not a bad sketch, that's about right. And that's the point 0, 0. So here's the equation. They've given me this lovely little cubic curve. As you can see, x to the power of 3 gives this lovely characteristic shape. Really beautiful. And it says that the graph passes through the point 2 minus 6 and 3, 10. And part A says the graph crosses the y-axis, at point A. There it is. Write down the coordinates of point A. Now, if you imagine a straight line graph where we have a y-intercept, we're looking for the number right at the end of the equation where it's not attached to any x's whatsoever. So actually what we're looking for is that hint there. So this coordinate for A is going to be 0 minus 8. Alright, so if you like, this part behaves, and you can even call it the y-intercept on the graph. And there it is. Point A is therefore 0 along, 8 straight down, minus 8, and there's the minus 8 there. And that's it. Nothing to do with trial and improvement, but it's a good little starter question. Gets you a mark anyway. Now it says use trial and improvement to find the solution of that equation. So here we go. But thankfully it's a sensible question. Give your answer to one decimal place. Now let's get logical. We'll try and make it all fit here. So x will be the trial. Here's the calculation. And here is the comment. Do this, the usual thing. Now, truthfully, and think about it, I've got two trials ready-made. I know that when x equals 2, look, the y is going to be minus 6, okay? So it's 2 across, 6 down, 2 minus 6. But I want to show it for completeness sake, and that's what I did on my little working out earlier. So I've got 2 cubed, there's the power of 3, minus 3 lots of 2, there's the times 3 times 2 there. Then I want to take away the 8. Well, that gave me minus 6. Clearly too low, because I know the answer is going to be between 2 and 3. See, 2's there, 3's there, and this solution here, where y equals 0, what's the equation? Yeah, where y equals 0. So I've got to solve this. Look, x cubed minus 3x minus 8 equals 0. Therefore, I'm looking at the where the line crosses the line y equals 0. In other words, the x-axis. So you can see if 2 is about there and 3 is about there, I've got an answer line between 2 and 3. Alright, so I know the first answer is minus 6, and that's going to be too low. And let's play with whole numbers at the moment. X equals 3, so 3 cubed minus 3 lots of 3, take off 8. That gave me 10. Not surprisingly, look, 3, 10. There's the y solution. There's the y solution there, and that's too high. What do? There's only one decimal place. Plant it right in the middle. So x equals 2.5. So here we go. 2.5 cubed. Take away 3 lots of 2.5. Subtract 8, and I got 0.125. Still a little bit big. Remember, the target is 0. Too high. Now I'm only allowed one decimal place, so I'm not going to start going 2.49. I'm just going to drag it down to 2.4 and see how wildly out that is. So here we go, 2.4 cubed minus 3 lots of 2.4, take off the 8, and that gave me minus 1.376. Let's just bring it closer together there. So minus 1.376. Too low, because I want to aim for 0. So what did I do? Try 2.6. Did I try 2.6? That's a silly thing to do. No need to do that. Look at that. So that's gone a bit too high. That's gone a bit too low. Therefore I must choose between 2.5 and 2.4. Now, do I need to calculate this? Can you see that 0.125 is a lot closer to 0 than minus 1.376. But in case we're going to lose a mark, is it 1.376? Yeah, 1.376. So let's just do a test now. Comparing 0.125 with 0. The difference is 0.125. Is that okay? I know this is overkill, but anyway, it's the last question. Comparing minus 1.376 with 0. The difference is, it doesn't matter if you go plus or minus, it makes no difference. You look for the absolute difference, the absolute distance away from the 0, whether you go above it or below it. Alright, so comparing minus 1.376 with 0, the difference is, no surprising then, minus 1.376, or basically forget minus, the difference is 1.376, and clearly that is bigger than that. Therefore the best solution, just highlight it, is that one, because that gave the best solution that was closest to 0. So best solution, x equals 2.5, and that's to 1 decimal place, and that is it. I think that was a proper AQA question that was 5 marks, 1 for spotting coordinate A and 4 marks for doing this little rigmarole. Don't forget, you've got to try and show you've made a decision, not based on guesswork but based on a bit of mathematics. Okay, we're done, and we'll catch you in part 14 very, very soon.